Okay, I think we're live. I don't think anybody's watching this because this is my very first attempt at streaming. Um, let's see. But I'm excited. We'll see how it goes. So in this first episode, we're going to look at some best practices for creating your first .NET project. I'm going to take each these best practices a step at a time, and then I will show you how to do all of it very easily. I don't want to start with all of it very easily now because it might actually overwhelm you with how many things that it does. So let's start out with I uh, I have a Git directory, but that's the wrong drive. It's on my D drive. Um, and let's create it. Let's call it Hello World. I use PowerShell, by the way, because PowerShell rocks. Um, but I'm also using the new Windows terminal from the Windows Store here, so I can easily create new tabs there. And in fact, I have created some profiles so that I can actually get the developer prompt from Visual Studio in here. So I'm actually running one of the preview versions of Visual Studio, so that's why it says int preview there. I always start with a Git repo, and I also always start with a Git attributes file um, that makes sure that the files will get checked out with the same line endings on every machine, if that's what I want, at least so that you don't stomp on each other. Without a Git attributes file, people with different Git configurations or different operating systems, when they commit, they change the line endings, and it causes the big red and green wall of death in the diffs when you're reviewing it. It's terrible. And the easiest way I know to get a good Git attributes file is to copy it from someplace else. So there you go. And I'm going to get a git ignore file as well, but I think I'll get one from a newer repo. Git versioning. Boom. Okay, so now I've got my two starter files. Now, I also always like to put my source code in a source folder. So we'll create that. And let's see. Now, honestly, I will typically do this in Visual Studio, but we'll do command line today. Because Visual Studio doesn't make it easy to create the directory and a source directory underneath it, and then put the solution file under that. So this actually does make it easier. Now I call that source solution, so I'm actually going to rename that Hello World Solution. Now .NET new class lib, we'll call this mylib for now because we lack creativity. Let's see. So got my library. My solution file is actually empty. So at this point, I'm actually going to go to VS Code because that's awesome. So here's my source directory. Here's this. I've got my terminal here. And you can see my solution file is empty. And I don't actually care for the processor architecture specific solution configurations either, so I'll get rid of those. Then .NET solution add mylib. I thought that worked. Maybe not. Oh, I'm not under the source anymore. Whoops. Okay, let's try this again. There we go. Boom. So that's nice. So this is a solution file that's going to work right inside of Visual Studio now. So we'll go to that soon. I have a simple project here. I want to add versioning to it. So all I do is .NET. I already ran the .NET tool install global nbgv command. So I have that at my disposal. So I'm just going to say nerdbank git versioning install. Oops. So what that did is it created a directory build props file, which just adds the nerdbank git versioning package to every project. It doesn't infect project package dependencies if I build a package though, because it's private assets all. And then it created a version JSON file. So I'm going to be building 1.0 beta up front. And whichever CI system I'm using, whether that's Travis CI or AppFair or Azure Pipelines, which is my personal favorite, it's going to set the cloud build number on it automatically to match whatever I'm building in the version number so you can recognize it, which is super awesome. So let's see how that looks. So if we say .NET Pack at this point, notice the version number is 1.0.0 beta because we have beta here in the version. So we've done a lot here. Let's commit. Stage everything. First commit. All right, now let's build again, or pack again. Watch this. All right, what happened here? Now we have a pack that's 101 beta instead of 100 beta, which we had before. Why is that? That's because this is a Git version-based solution. So every commit I make increments the version. So you're guaranteed to have a unique package version for every single commit. So you don't have this package cache corruption problem where everybody's building 100 of the package, and then as part of testing it, maybe you've consumed it in another project, and so that package went into your package cache. Because watch, so if I go into, check this out, I can go into my package cache here. And if I go into one of my projects, let's say NerdBank, Git versioning, okay? Each package version has one folder here. If you've built the same package version from multiple commits, only the first one actually gets expanded, and then it will quietly keep using that version, even though you thought you had built a new version of it. Anyway, it's a real problem. So it's really healthy and good to have your own package, a unique package version for every single commit. So that's that. Once you're in this world, program CS, wait, where's my source code here? Oh, class C1. Okay. So NerdBank Git versioning also gives you a this assembly class. So you can actually, I'm not sure if VS Code is going to show this. It did type it out. Oh, I'm not actually in a valid context. Foo. Let's actually go here. This assembly dot, and now it actually generates code for me, so I can at runtime figure out what version I have of anything, so I can see more than just version. I mean, I can get the git commit that produced this file, and this isn't using reflection. It's not using your git history anymore. This is actually burned into the code. If I say go to definition, you can see when my project compiles, it actually has this internal static class with all of this information, all the stuff you wanted, and including if I did have a strong name, that public key or public key token that's so hard to get to, but you need for things like internals visible to, that's all here. So it's super, super accessible, which is nice. So that's that. Now, I might want, there's so many other things that we could do. I see I've got a couple viewers now. I don't see anybody chatting yet, though, so feel free to drop in your questions as I'm going, if I'm not covering something well enough. I also like a read-only source tree desperately. Like, I hate that I've got this nice source directory here, but I've got this ugly file with a folder with a whole bunch of files sprayed in it. Also, it doesn't make it easy when you actually get to building in a pipeline and shipping. I want one directory with all of my NuGet packages in it, right? I mean, suppose I had .NET new class lib, my second lib here, okay? And then inside my second lib, .NET new add reference my lib. So now I've got this project reference, right? And if I pack, now I've got two packages, right? And .NET did this really, really well where I now have, oh, where did they? I don't even see my second lib. Why didn't my second lib? Oh, because it's not my solution file, right? .NET solution add my second lib. There we go. So now I've got lib here. And if you look at the new spec file that it produced, just somewhere, here it is. New spec, come on, debug. It's hiding under here. Okay, there we go. So it turned that project reference into a package reference, which is great, but if I want to ship, I need to ship both packages, right? So what do I have to do? I have to fish into bin/debug and get this package, and I have to go fetch it from this one as well. That's not easy for me to do if I was pushing manually. Of course, I shouldn't be pushing manually. All of this should be coming from my Azure Pipelines that automatically does it, right? But then you have to do */bin/build configuration / basically you're scraping the entire repo for NuGet packages, and you're just going to push them all blindly. I hate all that, right? I want a top level, this is what I want. I want a top level bin folder, maybe a top level OBJ folder as well, where all of my binary outputs go to, especially my packages. And so this is where we get more into, you can customize this. You can go to directory build props, and you can say, and I'm actually going to steal this from another place, because why type it twice, right? This is what I like to do. Oops. So over here in directory build props actually belongs in source. So I'm going to move that up. I did a property group, of course. And this is actually why I also use, I love VS. VS is an awesome product. I work on it full time for my job, right? But I like using VS Code when I'm doing build authoring or repo structure because it's just so fast responsive that I can do anything to any project file, whereas VS sometimes tries to protect you from certain kinds of changes, although it's getting better in that regard. But now check this out. So the repo root path is now going to be the one level up, which is the actual repo root, not the SRC, which is great. And then I say my intermediate output path should be OBJ at the top level, and then my base output path should be bin top level. So now when I say .NET Pack, watch where things go. So this is interesting. I'll get there, but notice I do now have a top level OBJ and top level bin folder. So I'm getting closer to where I want to be. These errors are because now that the OBJ folder has been redirected, it has the globbing patterns that automatically find all source files are no longer ignoring the subfolders here. And because I had already built once, it's now finding these things that, in this case, Nerdbank Conversioning put there and the .NET SDK put there. So I actually have to go manually delete these once. Or if I just make sure that Git knows about all the files that I actually care to track, like that, what I would prefer to do is just come over here and say git clean fdx. Boom. So now everything's super clean. Even not the top level bin obj because I'm actually in the SRC, but you notice now I've got a clean read-only source tree, so I can go .NET Pack. Hey, C# Fritz and Marco. I'm not quite sure how you pronounce your last name. Thanks for the follow. So now I've built, and I still have a pristine read-only source tree, which I love. OBJ and bin still are up here at the top level. Now I still have my NuGet packages in individual directories, which is not what I want. Because what I ultimately want is one folder with all my NuGet packages so I can just do a wildcard push of all of them to NuGet.org or whatever other feed I want to go to. So there's one other package output path. I like to add that property. And then check this out, .NET Pack again. So this time I've got one bin folder for each project, but then I have this one consolidated place for packages. So I can easily see all of them there. I can easily clean it. It's really nice. Hey, David, thanks for the follow. So that's nice. We're getting closer to where I like to be. Now, C# Fritz had an excellent stream this morning, which is my one and only intro to Twitch before this point. So that I learned a ton from that, and I've got so much to learn. Let's see. Hang on. Speaking of things to learn, C# Fritz is telling make sure I have record past broadcast turned on so I can review. Yes, I want that. I kind of assumed it was going to be on anyway. I wonder how to turn that on. Is that something I do on Twitch TV? I'm using OBS to record this. Is that something I do there? It is recording. I wonder if I can upload the recording later if Twitch isn't doing that. So if C# Fritz, if you can tell me how to turn on the recording, I would be happy to. Locally works as well. Okay, good. So we'll resolve that later. But if I can get it to do it automatically, that's great. So anyway, so C# Fritz I can't lost my train of thought there. He was demonstrating. Azure Pipelines, and he wasn't using. I record locally as it's better quality. Okay, great. Sounds good, David. C# Fritz was down on YAML, which is fine. I respect that. I love using YAML for my build for all of my orchestration for cloud builds because it is version controlled. You customize your build, you get it just right in the cloud based on the layout of your source files, right? But that's today. What if tomorrow I decide I don't want this top level SRC folder, or I decide, hey, you know what, I don't want this special NuGet directory. I just want to put the packages under debug, right? Now my pipeline's out of date and I have to go update the pipeline. And but do I update the pipeline before I push this change or after? And what if I have a servicing branch where I hadn't made that change? Now the pipeline's just wrong and it's going to fail and I can't service my previously released packages. All that's bad. So I really like having an Azure YAML pipelines YAML file checked into my source tree with all of that. So we'll come to that, but and I'm not even going to demonstrate doing that manually because it takes a while. And I'm going to show you how you can skip all of that. Azure Pipelines, by the way, has a feature that will create the YAML file for you, which is a nice way to go, but there's just so much more to do that I never use that process. I use a template. Another thing I always do for all my projects is pin the .NET Core SDK version. This is super important because .NET Core SDKs, and it wasn't just .NET Core SDKs, every Microsoft SDK always breaks you. They ship a new version and they break you almost inevitably, or at least change it. In fact, if you look at the Azure Pipelines build log, I saw this yesterday, there's actually a warning that the Azure Pipeline itself is adding into the build log saying, hey, if you're seeing failures, we just updated all of our build agents with a newer version of the .NET SDK, so unless you're pinning it, you could see regressions. So, I mean, beautiful case in point. So I always pin the .NET Core SDK version, and then I'll periodically update it. But every time I update it, I test it and make sure nothing's regressed. And you know what? Sadly, a good percent of the time, something has broken, which is, again, why I pin it. So .NET new global JSON. So here's my global JSON file. It's pinning, whoa, see? And like if you're building inside, at least if you're building inside Visual Studio, it'll even warn you in the build log, hey, you're building with a preview version if you've got previews installed. I definitely do not want to be using the 5.0 SDK version. I want to be using something that's solid and shipped. So I'm going to pin 3.0.100. I think that's the latest version that's out right now. Okay, cool. Way to go, C# Reds. I think C#, yeah. C# and David are talking about resolutions, which is good. I'll review those later, but I think I'm recording at a maximum quality there. So I've got that, but here, the next problem you have is as soon as you pin it, it fails in two environments. It fails on the cloud build if the agent doesn't happen to have a close enough SDK version installed, and it fails on your colleague's machine, because it used to be that they were, if they got lucky, and usually they would, the latest SDK that they have installed would just work. But now that I'm pinning this, they have to have 3.0.100 or something in the 3.0.100 band. It could be 3.0.101 or something. And so they would get this error saying, hey, you don't have the right SDK installed. And people get upset and they send me nasties about why am I pinning the SDK version. Yes, I can bump up be happy to. Let's bump up the font size. If I can, whoa, nope, that wasn't. How do you do that in VS Code? The control mouse drag is not doing it for me. Control ++, yeah, I tried that. That's what gave, oh, well, no, I didn't. I must have done Control Shift+, and that's what screwed it up. So, okay, good. Hopefully that's better. Thank you for that feedback. Anyway, so pinning is great. It gives you stable, repeatable builds, and that's a big thing for me. I want stable, repeatable builds. I want to be able to go back 2 years later, or in Visual, when we work at Microsoft, we have to be able to build things 10 years later to ship servicing releases that are super high priority for security fixes or whatever. I need everything pinned so that I can come back to it and know that I'm going to be able to build it even with newer tools, right? Because if you don't pin this, guarantee whatever project you thought built 3 years from now will not build. And it's really nice to be able to do this. But again, it makes it less convenient today, potentially, because now your colleague who doesn't have this particular version installed fails. So how do you make it super easy for them to install the right version? And this is just the SDK version. Oh, okay. So repeatable builds, what I mean by that is it works on my machine syndrome. I built here, right? Like I built and I got version 101 beta. When the cloud builds this same commit, I want it to build this exact same thing. I want it to be reproducible. And if I come back 3 years from now and I branch from this commit in order to service it, and I push that branch to Azure Pipe, to my Git host, like GitHub or Azure repos, and then I tell Azure Pipelines, hey, go build that branch. Again, I want it to build it exactly the same way it built 101 beta last time, but with my one commit that changed things. And then, of course, it'll be 102 at that point. But repeatable builds are, I want to build it 3 years from now, or I want it to build on a different machine exactly the same way. So that's the ideal. This is one step of how you get there. It can make it a little less convenient, both for your colleague and because the Azure Pipelines agent may not have it. And even if one agent has it, it might not have it next year when Azure agents say, hey, you know what, we don't need 3.0.100 anymore. We're just going to put 5.0 on because 5.0 is the new big thing and no one's using 3.0 anymore. And so they uninstall it. Well, now I can't service my bits from 5 years ago because 3.0 isn't being installed anymore, right? So I actually I don't take any dependencies, if I can help it, on what software is installed on the agents in the cloud build. I want to have script that makes sure that my whole tool set gets installed if it isn't already there. And I want as much of what happens in Azure Pipelines to also happen locally. It's aggravating when you're writing Azure YAML, and maybe this is one reason why C# Fritz hates YAML. You can't reproduce it locally, right? There's no YAML execute function. AppVeyor actually recently added something like that, which is great. But I want to keep the YAML as simple as possible and have it just execute scripts that I can also run locally. So all of this coming into the C# template that I created. You go to GitHub, ARNet, and GitHub is awesome because it introduced this recently. So I decided I'd actually encapsulate all the years of learning and best patterns and practices that I've ever came across. GitHub now lets you create repos and identify them as a template. So you can actually say, use this template, and you can start your own repo that's based on this one, which is freaking awesome. Once you have it, so let's demonstrate this. And okay, there we go. So I'm just going to say git clone. I'm not going to use the GitHub approach because I don't want to publish a public repo. But over here, I'm going to say git clone https GitHub ARNet library template to hello world awesome. Because now I don't have to do any of this stuff and a whole bunch of other stuff, which we'll go through. So here's hello world awesome. Now I don't actually want to push to library templates. This is my repo, not Andrew's, right? So I'm just going to remove origin for now. So now it's your own, right? You can't push, and you can push to your own later. The very first thing you do, let's actually open up this this folder in VS Code now, so that it's showing the right thing. Hello world awesome. Now notice this expand template script. There's some placeholders in this template. I want to get rid of them all now. So expand template. That's nice. Okay, but I don't know why VS Code does this. Like I already had one open. You didn't need to open up another one and overlap. Here I am. So it'll prompt me to fill in the blanks. So this was hello world library author myself. So boom. Now it's going through and replacing all of the placeholders, and it actually removed itself. It deleted itself. Expand template is now gone, but now the library that was under here is actually called Hello World. And look, it gave you tests because everything you should do. Like if it's worth shipping, it's worth testing. Shipping a library that doesn't have unit tests written for it is like delivering an autopilot airplane without ever having tested the autopilot. Like why would you? You're writing code that automates operations on someone else's machine. You ought to test it and make sure that it works. So gives you a test project, of course. It sets you up with, it's XUnit, and so it sets you up with this, which keeps certain things from breaking, but it doesn't come from by default, right? Here is the global JSON file, right, with a reasonable default for an SDK. Now, I was talking about how do you get it on your machine? How does your colleague get it on your machine? Oh, let's see, hang on. Would it make sense to build Docker images that contain source code SDK and source packages necessary to build an application in the future? Probably. I don't personally use Docker images to build software too much. I know that's really popular, especially in the ASP.NET world. Um, and for the sake of encapsulating all of your SDKs and tool sets and things, I love that idea. In fact, I actually spent a few days, several months back, trying to. In fact, here, let me show you what I did, because it's still there and it works, and I do occasionally use it. It's called, let's see, Win Build Agent, I think. What did I call it? I have a Docker image. I have a Docker container that does this. Let's see, build agent. What's that? It's just been a while since I've. Okay, here we go. Win build agent and Linux build agent. These are Docker files that create Docker images that you can use to build software that includes a whole bunch. And this is stale. I actually do have 2019 on it, I think. But this installs VS. It installs NPM. It installs Python. Older versions of MS Build, because older versions of tasks that you might be using, it installs Git for Windows. So the idea is, if you built your software, I think is what C# Fritz is getting at, if every time you built an Azure Pipelines, or possibly even locally, you did your build with all the tools that came from this container, then you're guaranteed to be able to reproduce it later, even if the entire build environment has changed more than your scripts could anticipate, which is a great idea. And Azure Pipelines actually supports this. You can specify in your YAML, hey, go get this image, and then do everything else from within it. The reason I don't typically do that, though, is because this image is a few gigabytes, and it actually takes a couple minutes to download that in an Azure pipeline, so it slows my builds down, because most of my builds are really fast. And it's a cost benefit thing, right? If I was building Visual Studio, something that absolutely has to be serviced for 10 years contractually, I would do it within a Docker container for sure. Most of my projects, though, I consider that if I'm pinning the .NET Core SDK, that's good enough. But very good point. So what else have we got? We've got an init script. This is your friend. This is your buddy's friend. This is what does all of the installation of prerequisites. So this will actually look to make sure you have the right .NET Core SDK installed. In fact, there's more than just SDKs, right? If you look at a test project, notice, so I'm testing my library, which is a .NET Standard 2.0 library. Great, you can do almost anything with this, so I only build it once. But I actually want to make sure that my library works properly on .NET Core and .NET Framework, right? So I'm multi-targeting in my XUnit test project. And I therefore need, both locally on my box and in the Azure Pipeline agent, I need the runtimes for .NET Core 2.1 and 2.2 installed, okay? This init script invokes another script called install.NET SDK. This actually not only looks at your global JSON file, but it actually looks through all of your projects to figure out what runtimes you need and installs them all. So I can just run init ps1 and see what it's doing. It makes sure that I have the NuGet credential provider installed so I can download packages if I have authenticated feeds. It's making sure that I have 30100 SDK installed. It's making sure that I have the 2.1 and 2.2 runtimes installed, and I already have all of them installed, so life is good. It sets them now and then it restores packages, right? Now the .NET Core runtime and SDK awesomely can be installed without elevation. And if somebody had cloned your repo and you don't trust them, like the last thing you want to do is say, hey, you can't build my project without elevating to admin and run my init script. Like I would shy away from such a repo. So the default behavior of init is to install them into per user location so that no elevation is necessary. And that's why we're modifying your environment variables so that now you can just run .NET build and you know it's going to work, or .NET test. And if you launch the solution file from here, that would also work. But if you didn't have the SDKs installed in a per machine location, Visual Studio won't load the solution if you just loaded it from a shortcut. Like if I just launched VS here, it's not going to work. So you can also run init and say install locality machine, and then it won't shrug at making sure. So right now it's downloading. It can't actually tell that I do have this installed machine-wide. I haven't made the script to do that yet. So it's downloading the SDK installer, and now it's wanting to elevate. And if I'm willing, and you can't see it on the webcast probably, but there's an elevation prompt that I just accepted. And then the installer actually notices, oh, it's already installed, so it's going really fast and it's just moving on. But the point is you have to opt in to requiring elevation, which your colleagues will want to do so that it always just works in Visual Studio. Um, but the point is it doesn't require elevation. Now, I have Azure Pipelines. I have a bunch of scripts here that make things work great. Let's start with the first one, though, because this is how init helps you not only locally but in the cloud as well. So I have this standard one. It's here in the root because that's where Azure Pipelines looks for it. But what I've got more than I want to just. I want my root directory to be nice and clean. So I only have the one file, and it just points into build YAML. So let's look at build YAML. And because I'm a this is .NET Standard, right? We want it to run on Mac, Windows, and Linux. So I actually do the build and test on every operating system here. And I share a lot of build steps. In fact, I'd like to share them all. So I actually put all the common build steps inside .NET YAML. And before I do that on each one, I install dependencies. Now this YAML file runs, guess what? Init. Yay. So we've got common shared script locally that I can run, and it's the same script that works in the build agent. So it's going to work everywhere is the point. Now, and then it sets the variables, which we can go into that maybe in another session. We'll see. But over here at .NET YAML, we've got .NET Build. We add no restore because init already did that. We always capture build logs, right? If you've got a failure in your cloud build, you want to be able to get everything you could possibly need, especially if you can't reproduce it locally. Like, why is it failing? It works on my machine. You always want the build. Artifacts are cheap. Always collect as much artifacts from the cloud build as you possibly can. You don't ship them all, but they're good for diagnostics. So we've got a verbose log going into build logs, and then we pack with no build. We run tests on .NET Framework and both .NET Core runtimes. And then more pipeline variable stuff, which I'll go into another time. And then symbols. Symbols are so important. It's often overlooked. You want to archive your symbols, and you actually want to share it with the community if you're doing an open source project too, and maybe even if you're not. So that this archives the symbols, indexes them, and over here, let's look back over here at symbols. Maybe one day this will be the default, but it hasn't been for a while. You can turn on, you notice, let's do a build. I don't know if I've actually done a build here yet. Here's my packages folder. So not only do I have a NuGet package, I have an SNuGet package. This has the PDBs in it. And when you push this one, the NuGet push command will automatically also push this one. So that then in Visual Studio, we'll bring this up because this is fairly new, so it's probably worth showing off. Customers will love you if you're doing open source and they can step into your code easily. Symbols. Here we go. NuGet.org symbol server. Make sure that's checked. Tell your customers to check it. Because then when they install, when they're stepping through their code that consumes your library, they can step directly into your source code and it downloads from GitHub or whatever your Git source is. And again, that it doesn't necessarily include the source code. So if your source code is actually locked up in some authenticated Git server, this doesn't mean that you're giving away your source code by another channel. It just means that they can get to it if they have access to that Git repo. So that's cool. Embed in untracked sources. So if you've got source code that's produced by the build, like that disassembly folder or file, for example, it will actually put that in the PDB because you can't get it from Git later. So David asks, why not just rely on SourceLink? I am. There it is. SourceLink doesn't give you a place to push the PDB to. I use SourceLink to, it processes your repo and things. It doesn't even post-process the PDB anymore, which is awesome. It creates a JSON file that goes into the compiler so that the original PDB produced by the C# compiler can include all of the Git information necessary so that later Visual Studio can look at the PDB and find the source. So there's several links in the chain here for this to work. You have to produce the PDB. The PDB has to have the Git information in it. And then you have to put the PDB someplace where they will find it, which is what this SNuget package is for. Then you have to tell Visual Studio to look in the NuGet archive, the symbol, the index, the NuGet symbol index. And then when VS will download the PDB, it then finds the Git information in it so that it can download the source file. So yeah, source link is great, but it doesn't come for free. You have to actually reference it. So it's in the file here. NerdBank Git versioning, which I showed off earlier, is of course here. We've got the version JSON file here. Now, just to briefly explain this, what this means is if I'm building out of master, I get the nice version number, right? I already built it. So I'm getting 0172 beta. If I was in a non-master branch, let me bring this up and pin it so it stays up. Okay, so let's create a topic branch here. Let's see. David says, oh, I thought with source link and embedded PDBs meant you didn't need separate simple files. Oh, I'm not embedding the PDBs. That is an option. I can set an MS build property to actually put the PDB in the DLL itself. And then, yeah, it's just there. And the newer PDB, old Windows PDBs were enormously huge. So you didn't want to bloat your DLL with a PDB that was 4 times as large. But the new .NET Core SDK produces what they call portable PDBs, which aren't Windows specific anymore. And thank you. They're so tiny that, yes, you can make the case that you just put in the DLL. And the Roslyn team actually has a super complicated process by which they decide whether to embed the PDB. The downside of embedding the PDB in the DLL is image size. It might be that it's insignificant, but in Visual Studio, for example, when we're dealing with a 32-bit address space, we want DLLs to be as small as possible, because every DLL, if you grow the DLL by 32K, well, that's 32K of address space that can't be used for data anymore. So I don't typically do that, but it's certainly an option. So let's create a topic branch. Now I'm on topic. I haven't actually changed the commit that I'm on. In fact, is my commit clean? Yes, it is clean. So now if I do .NET Pack, watch what happens. Now again, the commit hasn't changed, so the commit height is the same. It's still 0172. But because I'm no longer on a public release branch, that is, it adds the git commit ID to it. And as Jeff discovered this morning, the G, I have to add the G. In this case, it would work without it, but if your git commit starts with a 0 or has just numbers, suddenly a lot of tools and Semver and things freak out because, oh my gosh, you can't have an all number suffix. So I put the G there so that it always just works. And you just have to know if you want the commit, skip the G. G is not a valid hex character, and git SHAs are all hex. So you know the G can't possibly be part of the commit ID. Anyway, so that's what the public release ref spec does. The idea is topic branches aren't linearly versioned, right? Topic branches could have the same git version height. So you'd end up with 012 being built twice from 2 different topic branches, but they're different commits. So it's important as part of the unique versioning system to add the git commit to the package version unless you know you're in a branch that guarantees uniqueness, which would be master or your servicing branch. This regex matches v1.0 or v2.0, and you can change this, of course. So if you're in a servicing branch, you're going to get the nice version as well. You're only going to get these kind of nasty looking version with commit ID in a topic branch, which is on your private box, so that, again, if you're looking at your package cache location, it will create a separate folder for every single commit that you're building in this topic branch so that you don't suffer from, hey, I fixed this bug and packed it. Why, when I consume the package, is the bug not fixed? And it's because you've polluted your package cache and you built the same package version twice. Well, anyway, so it solves a lot of problems and frustration and possibly hours of investigation for why a bug fix didn't work when you actually did fix it. Okay, moving on then. So what I did here, the template drops you into C#8 world because C#8 is awesome. It turns on nullable refs, and this, I probably don't want to drill in too much, but it's awesome too. Let's go ahead and open up VS. just so you can see it, because again, it's so new, it's worth at least showing you what it is. And there's not a single reference that I can use here. All right, so let's just create a fake void foo object o equals null, console write line o.toString. Now that's going to throw an exception at runtime, right? Because I'm dereferencing null. That would be a problem. C# is going to call that out now. I'm going to make this static so that one's happy. But you notice first it says, hey, I'm assigning null to a non-nullable ref type. And then it's warning me, hey, you're dereferencing something that's probably null. I'll zoom in here a little bit. Okay, so Tagron1 says, can the version file be on the solution level or is it per project? So when you run the nbgv install tool, it will put it in the root of the project, or sorry, the root of the repo, because usually you want all of your packages that ship together from one repo to have the same version. So my recommendation is typically put it in the root of the repo, but you can absolutely put version JSON files in other locations. It can be in your project directory or anywhere in between, so you can influence whole trees of projects. And you can inherit, you can change the version, or you can tweak certain parts of the version. Version JSON file lets you do all sorts of properties, and you can customize them in certain sub branches without changing the version. You can do all sorts of stuff. Anyway, so hopefully that answers your question. So the first thing I need to do is fix this and say, okay, look, this variable can be null. So previously question marks were only allowed on value types, like structs, but now you can put them on ref types. And then over here, it still says, hey, well, this could be null, which is absolutely true when I have a bug, but now I can discover this at compile time instead of at runtime, which is so awesome. No on repo is very fine with me, exactly what I need. Okay, good. Glad that addresses the concern. So now if I say, look, it's an empty string, not null, the warning goes away. So nullable ref type saves you money. It saves you time because you don't ship bugs. Highly recommend. Any new project should absolutely turn it on. Any existing project should schedule time to go and turn it on and then go add all of the nullable type annotations like this so that it can help you find those bugs in the future. So we turn that on. Always, always, always turn on generate documentation file. Not only does that give IntelliSense to your consumers, but even if you don't care about the documentation, it turns on extra validation in the C# language. So for example, check this out. Like, let's say I renamed a parameter and I forgot to update the documentation. See that little squiggly that says, hey, you got it wrong? That wouldn't come if generate documentation file was off. So this just gives you goodness. It helps you keep your code healthy and clean and accurate. And if you don't do this, because, well, now I get all sorts of warnings about so like here. So let's just delete it. So now you get a warning because I turned on generate documentation file that, hey, you haven't documented a public API. And even if you decide, that's not a priority for me, then you can just go disable the warning. You can say no warn CS1591. Guess how I memorized that? And then come back over here, and the warning's going to go away eventually when VS discovers that I changed the file. Yeah, it's gone. No? Oh, that's style cop now. So now C# is happy, but style cop I also have saying, hey, you should document everything. So you could turn that off if you wanted to too, which brings me to, yes, I also turn on style cop because honestly, like even if you don't agree with all the styles, you can always turn them off if you don't agree with them. And in the meantime, they help you. If you've got style cop on in your open source library, it prevents PRs that look like that. Like people will get white space wrong, and at least if you're obsessive compulsive, like I guess I am, it just bugs the crap out of me. Also, and even if it didn't just annoy you, sooner or later someone else is going to make another PR where they happened to define a new, like if they it's easy to trigger an automatic document format, and then C# is going to fix it, and then the subsequent PR, which didn't change this method at all, suddenly includes a diff of white space, which is annoying to everybody. So what I like style cop for, if nothing else, is it kind of enforces that the effect of format document is always done, so that you don't have these messy PRs coming in all the time. So let's see what else we got here. Reference assemblies lets you target .NET Framework off of Windows. which is super cool. Um, let's see. Oh, yeah, they finished that. I can actually get rid of the preview on there. Um, and then FX cop analyzers because, again, more analyzers are generally better. You can always turn off an individual rule if you don't like it. Let's see. So in addition to all those version properties that Jeff was talking about this morning, I also have FXCOP rules enabled, says Tagaran. Good, excellent, good stuff. Keeps you good on security. A bunch of other bugs get avoided as well. But in addition to all the version attributes, there's a whole bunch of other properties you should set in your NuGet package. And these get set in the NuGet package and in your assembly metadata, which is awesome. It says my name because I ran the expand template script and put my name there. So it'll say your name when you do this. Also, the expand template script creates a new strong name file for you. It doesn't reuse mine. You get your own. But it does check it in unencrypted because strong name signing is not about security. It's about namespacing so that if you have mycoolutilities.dll and someone else does, they don't conflict because they have unique strong names. Also, if somebody is strong named, they can't reference your assembly on .NET Framework unless you are also strong named. So if you strong name, everybody can reference you. If you don't, some people can't. So if you want to increase your impact, strong name your assemblies. Let's see. Let's see what else we've got here. Build targets. So code coverage. Really nice to have. Really nice to collect. So we use the coverlet package. Yeah, coverlet MS build in your test project. Again, it doesn't come for free. Maybe it should, but it does with the template. So now when you run it in Azure Pipelines, you get code coverage results. You actually can get code coverage results running locally as well. Let's jump back to this test. I pointed out that the pipeline ran the tests, right? Remember, each of these things, we were running it on .NET Framework and .NET Core twice. But each of that happens on Windows, Mac, and Linux. So you actually have like 9 test results because each operating system ran 3 times. Or possibly you didn't run the .NET Framework one on Mac and Linux unless you're using Mono. But that's a lot of test results, and you want them all surfaced because maybe a test only fails on .NET Framework on Windows or .NET Core 2.2 on Mac, right? You never know. So you want to collect all that, and you want to collect the code coverage from all of them. Turns out that's a really hard thing to get right. I spent days trying to figure this out. So again, it's all in the template for you. After each thing runs, there's a wrap-up step, which will take the code coverage and test results and publish them to Azure Pipelines. So I'll show you what that looks like. And Tigron says you can use .cover from JetBrains' console version for free to have coverage. I haven't tried that. I'm sure that's true. Coverlet is free, and I'm pretty happy with it. Maybe JetBrains is better. I'd be interested in learning about that. So if we look at library template, this template was very carefully written to be completely self-demonstrating, as well as ready to go for you as well. So actually the template acts as its own project in its own right. So if we now let's look at the latest CI build from master. Notice the NerdBank Git versioning label here. I've got tests. So here are my 3 operating systems plus the wrap-up step. If I go to tests, I see I have no failures. If I clear that filter, you can see, and they're all labeled. Also took some work to figure it out. You can see, okay, this is each. So you can see we're running .NET Framework tests only on Windows. And then you can see the .NET Core running on each operating system. And you can drill in, and you can get the logs from each of these tests. And then over at code coverage, I can see my library calculator class has awesome coverage. And the disassembly class that was injected doesn't have anything. I should probably actually mark that as exclude from code coverage so that it doesn't show it as red. But this is code coverage that is the aggregate of all of the test runs from all 9 times. So you can really see if you haven't covered anything anywhere, which is great. Let's see. Also built into this, if you haven't seen codecov.io, it is pretty freaking awesome. It will add to each pull request when you. Here, I'll show you that too. Let's go to a pull request. So here it is. To every pull request after the tests run, the Azure Pipeline script pushes the code coverage results to codecov.io, which then puts a comment on the pull request that explains the impact of this change. So you can see, okay, well, before and after, like it's awesome. It's an amazing report. It's very insightful when somebody's adding a pull, sending you a pull request that adds a feature. You can clearly see, oh, you didn't adequately test it. And then you could actually drill in and see, okay, well, what didn't get covered or what did. So this is a nice, you can see, okay, these two lines got covered. So this codecov.io is a great UI. It's friendlier than the Azure pipeline. I mean, it's cool that it's surfaced here, but I don't know, it's kind of uglier. So I like codecov.io. So this is integrated, and you can turn that on or off. Like all of this stuff, you can turn on and off if you like or dislike. I think I'll save this stuff for another session if people are interested, or I can do it now if you chat and say you want to learn more about that. Suffice to say, though, if we drill in a little bit to Windows here. So now Nerdbait Git versioning will set the build number for you automatically. You don't have to do anything special in your pipeline to do that. However, if you have multiple projects or multiple agents, you tend to not want to bother setting the cloud build number repeatedly, because every single project build will set the cloud build number and then they'll stomp on each other. And usually that'll be the same number. But so I set the build number once on my Windows agent explicitly using the nbgv cloud number command. And it builds, it packs, it runs the tests, and then it captures a whole bunch of artifacts. I talked to you about build logs. So over here, I've got 18 artifacts. So lots of build logs, so I can drill in all that. Code coverage reports, the deployables. So these are the packages that were built on Windows, packages that were built on Mac. Hopefully those are the exact same thing, but you might decide, hey, look, testing on Linux is enough. I'll trust that it works on Mac, and you turn off Mac. Oh, well, David, I'm impressed that you're up at 7 a.m. watching videos. It was nice seeing you. Catch you later. Yeah, I'll upload to YouTube or maybe Twitch if I can do that after the fact, and I'll send out a tweet on Twitter pointing to it. Project Assets.json helps you diagnose weird, bizarre failures in package restore. And then here are my symbols, so I can archive them later if I really cared to. So basically, you saw how trivial the library itself is. This is just a starter template, but it has everything in the kitchen sink ready for you to go, so you can be entirely successful with tests, versioning, deployment. Heck, it's even got stuff to automatically push in your CI build to a feed, like your Azure Artifacts feed privately. And then it's a fairly trivial matter for you to just create a release pipeline that will then copy those artifacts to NuGet.org. So that's, and then rule sets. It disables one rule. I don't even know what that one is, but it's generally disagreeable to me, I guess. And one nice thing, because this is all GitHub templates, is if you disagree or you want to build on top so that you can use this template but do the things that you typically will do, you fork the template, build on it, and then periodically merge from mine or look at what I've done and see. It's super, super convenient. I wish Visual Studio's new project dialog would pull project templates from here, like from GitHub templates, because it open sources the template system, which would be friggin' awesome. And it gives you some badges, or it encourages you to use badges and gives you a nice looking README file there. So anyway, that is all I planned to cover today. Send me messages, send me tweets or something if you have questions that you want me to drill in on later. Otherwise, have a great day and happy holidays.